artificial intelligence. This AI is not only the applicable to only electronics people or only computer science people. It needs the creative thinking, explicit knowledge, language aptitude, numerical reasoning, verbal reasoning, working memory, the critical thinking. All these particular interdisciplinary domains which are needed with respect to this AI. So when you see the AI hierarchy, there are different the blocks will be there. So deep learning, machine learning, and the artificial intelligence. Artificial intelligence is simulation of human intelligence processes by machines, including learning, reasoning, and self-correction. Machine learning is an application of the 1 minute. That's me. So machine learning is an application of the artificial intelligence generating systems that can learn and improve without being programmed. Then the third one is the deep learning. It is a subset of machine learning and artificial intelligence, creating and training neural networks that are considered highly promising decision-making nodes. So these are the what you can say branches where the artificial intelligence consists. Now, coming to the classification of AI, there are two types of classification. One is based on the capability, based on the functionality. Based on the capability, weak AI, general AI, and super AI. Based on the functionality, we have a reactive mission, limited memory, theory of mind, and self-awareness. So these are actually weak AI means here the narrow AI, which is dedicated for the one task. General AI means performs like a human being, and super AI is intelligent than human. So these are the three different types of the classification based on the capability. Based on the functionality, we have reactive mission, then limited memory, then theory of mind, and self-awareness. So these are actually different types of the classification based on the functionality. Now, if you want to design any AI system, okay, depending upon different the problems, so you can see that the design of AI system consisting of 5 steps. One is first get the data, then clean and prepare, manipulate the data, and training the model, and testing the data, and improve this particular data. So any problem, either it is a societal problem or any general problem, a share market problem, whatever the problem that we will consider. So when you want to design AI system, these are the steps that are needed. Getting the data is very, very crucial. So data collection is very important in any particular problem. After collecting that particular data, so we need to pre-process that particular data. So pre-processing of a particular data means cleaning, preparing, manipulating the data. And afterwards, with this particular data, you need to train the system. And after training the particular system, among this particular training data itself, you will take some sample for testing that particular data. And if any particular remarks are there, you need to improve. So there is a feedback system, a closed loop system that will come into picture. So these are the steps, whatever I discussed. Now, there are different research areas in artificial intelligence. Some of the research areas are related to AI, expert system, neural network, robotics, then fuzzy logic, natural language processing, signal processing. There are useful cases with respect to signal processing. You can see speech and voice recognition, voice assistant, emotion recognition system, and computer vision. So like that, we can have the various research areas in AI. So we can, as I said, the interpretation of the data, that we can do it with the help of signal processing using AI. Then if you want to design a signal processing system with the artificial intelligence, any particular application when you take, so then first the signal processing block will be there. This is a pre-processing. Then we need to apply the machine learning concept where the feature extraction, classification, and output. Then deep learning is when you want to go for the more accuracy, we can go for the deep learning, the classification and output. So this is actually input and signal processing, where the input, either it may be image, it may be speech, biomedical, or a combination of both. Taking the inputs contain a lot of redundant data, and we will find out the different features. If it is related to signal processing, like energy, power, loudness, brightness, intensity, we can take. And this is one example of image analysis. When you take a biomedical analysis, or some particular the image processing application, you can take the image capture, then basic image pre-processing, then apply the threshold technique to identify the region of interest, then image segmentation, feature extraction, and classification evaluation will come into picture. So I'm not going in detail about these things, feature extraction and the classification. Okay. These are the methods that we can use it. Okay. So classification, there are different types of the AI methods, the regression method or the neural network method, deep learning method, those things we will try to use. So coming to application of AI, so there is finance, data security, social media, automotive, robotics, entertainment, e-commerce, education, agriculture, transport, healthcare, astronomy, gaming. Like that, there are so many applications of artificial intelligence are there. So this is the, so we have seen till now the artificial intelligence. Now comes to the machine learning. Machine learning is actually field of computer science, which gives the computer ability to learn without being explicitly programmed. Okay, using data for answering the questions, the training as well as predicting will come into picture. There are three different types of machine learning: supervised machine learning, unsupervised machine learning, then reinforcement machine learning. So this is the supervised learning. We have a regression classification. In the regression, prediction of continuous valued output, then classify the things. So either email, spam or not. So given image, cat or dog, we can classify that. Then there are certain the regression and the classification algorithms, regression algorithms. So these are linear regression, polynomial regression, and the classification algorithm, support vector mission, neural network, k nearest neighboring. So these things that we will use it for classification. So this is actually the methodology how we can do the supervised learning principle from the input data pre-processing, then training, then modeling, then prediction and output. These are the steps involved in the supervised learning. Then unsupervised learning pipeline, there is the without having a supervisor, the clustering and the association will come into picture. So then this is the unsupervised learning example from the input raw data. So we need to take the data, interpret the data, apply the supervised learning, unsupervised learning, the algorithm, and we need to see that wherever the cluster came in output, that is nearest the points which we can gather, and based on that we can classify whether it is related to apple, banana or mango. So like that we can classify with the help of unsupervised learning. Similarly, reinforcement method, an agent interact with environment and watches results interaction. So environment gives feedback via positive or negative reward signal. So like this we can do it. Then so this is about the artificial intelligence and its applications. Now coming to the brief overview of IoT, the Internet of Things is a network of physical objects or things embedded with electronics, softwares, sensors, and networks. So IoT allows objects to be sensed and controlled remotely across existing network infrastructure, creating opportunities for more direct integration between the physical world and the computer-based system, resulting in improved efficiency, accuracy, and economic benefit. So a brief review on IoT. You can see Internet of Things. It is a system of interrelated computer devices, mechanical and digital mission objects, animals or people. They are provided with unique identifier IP addresses and the ability to transfer data over network without requiring human to human or human to computer interaction. So this is about the IoT, and you can see a place where missions talk to missions. This is called the Internet of Things. Then the term Internet of Things was first used by the Kevin Aston in 1999, refers to uniquely identifiable objects and their virtual representations in an internet-like structure. So this is about the IoT, how it is established. So when you see the introduction, the internet communication through network, either wireless, satellite. Things means electronic devices like mobile, computer, sensor devices, etc. And the internet, the IoT means anytime, any place, connectivity for everyone, connectivity for anything. And how the IoT works, It is a combination of, you can see, sensors, devices, then we need to connectivity, data processing, then user interface. So how does IoT works? Internet of Things is not only the result of single novel technology, and instead several complementary technical developments provide capabilities that taken together. These capabilities include communication and cooperation, addressability, identification, sensing, actuation, localization, user interface. So coming to the sensors and devices, as we have seen that these devices, sensors are key component that helps you to collect live data from surrounding environment. All these data may have various levels of complexities. Then connectivity, either by using the Bluetooth, Wi-Fi, WAN, you can connect. Then these are the connectivity modes. Then data processing. Once the data is collected, it gets to be clouded. The software performs the processing on the gathered data. This process can be ranging from the simple checking of temperature, reading on devices like AC or heaters, to complex data analytics of industrial environment. Then user interface, the information needs to be available to the end user. So we need to interface with a mobile. Okay, a user sometimes might need an interface with the activity checks in their IoT system. So this is the structure of IoT, consisting of tagging things, real-time item, feeling things. Sensors act as primary devices to collect data from environment, syncing things, that is miniaturization and nanotechnology that has proved the ability of smaller things to interact and connect within the things or smart devices. Then thinking things, the embedded the intelligence in devices through sensors has formed the network connection to the internet. It can make things realizing the intelligent control. So this is the enabling technology, RFID, to identify, track the data of things, sensor to collect and process the data, smart tech to enhance the power of network, then nanotech is to make the smaller and smaller things have ability to connect and interact. Okay, this is the some features. So this is anytime connection, any place connection, and anything connection. These are so many applications are there. Okay, you can see that IoT applications, home consumer, transport mobility, see light bulb security, pet feeding, irrigation controller, then smoke alarm, refrigerator, informative, washer, dryers, stove, energy monitoring. With respect to transport, traffic routing, telematics, package monitoring, smart parking, then supply chain, shipping, public transport, airline, trains. Then coming to the health body, we have a patient care, elderly monitoring, then remote diagnostic, equipment monitoring, hospital hygiene, then biovariable, food sensor. And coming to the buildings infrastructure, we have HVAC, then security, lighting, electrical, transit, emergency alerts, then occupancy, energy credits. And the cities industry, there is a electrical distribution, maintenance, surveillance, signage, so emergency service, waste management. Like that, we have so many IoT applications with respect to the home consumer, transport mobility, health body, building infrastructure, cities industry. And the IoT benefits to organization to monitor their overall business process, then improve customer experience, save time and money, enhance employee productivity, integrate and adapt business model, make better business decisions, generate more revenue. So here, Industry 4.0, it is associated with industrial IoT, network-centric, industrial app, quality, safety, automation, monitoring tools, and sensors. So why AI is important in IoT context? So AI will be functionally necessary to wield the vast number of connected things online. AI will be even more important in making sense of almost endless sea of data streamed in from these devices. You can see, so from the sensors, the data will process the sensor data, and after computing the safe the versus goals, we can have the actuator. AI provides us the framework and tools to go beyond the travel, the real-time decision and automation use cases for IoT. So there are certain constraints in AI IoT. for information acquisition, information processing, information communication, and information visualization. So these are the key tasks. As I told you that information acquisition can be done using smart sensors like RFID. Information processing can be done by AI algorithms to identify the changes in surrounding environment. Information communication, it is processed and the results generated using AI algorithms are communicated to end user using various communication methods like IoT, Wi-Fi, LoRa. Then information visualization, the data can be visualized in various modes like dashboard or messages in mobile, PC, tablet, etc. So some of these case studies are given as examples below. You can see that AI with the AI solutions. There is a video on AI IoT. Then AI IoT in agriculture, how Internet of Things is transforming the agriculture sector. You can see diagnosis of disease, variable rate fertility, water stress, auto spreading, the crop yield analysis, smart data, soil erosion, and field monitoring. So these are crop yield flowchart through internet, the field cultivation, drone technology, the satellite image, taking the local data storage, the crop health monitoring, soil nutrition measurement. So then the pesticide management. So like this, farmer can be benefited. The monitoring the smart farm, things of board, soil monitoring. Okay. So there is a dashboard that we can create and we will know which type of a soil, what will be the yield and what type of crop we need to keep, what is the water level, temperature level, soil weight, monitoring the events. Then feature of AIoT applications in agriculture, soil moisture and water purity, automated irrigation system. Then smart water management using AIoT. There are more yields with less water. You can see the sensing and activating the layer, processing and storage and service layer, application layer. Then smart water management using AIoT. We will know that the water level sensor, there is a EC05 soil moisture sensor, integrated design for sensor. You'll know the water level. Then this is the smart water management using AIoT. Okay, so we know that particular levels, smart water management using healthcare monitoring system using AIoT, telemedicine and remote healthcare, emergency responsive time, real-time patient monitoring, and digitized medical history. There is a development of the wireless body area network. Okay, so there is a communication protocol is used, IEEE 8001 801.15, power management and data tuning, calibrated the data, filtering and noise removal. We will know different the position and the master checkup we can do with the help of this particular AIoT. Healthcare monitoring system using AIoT web interface, and we can see the data recording the medical history and sending feedback. Then healthcare monitoring system using AIoT. We can develop the system architecture for multiple hospitals. Then system trials, hospital system trials. Then healthcare, we have seen. So industry 4.0, a new heavy trend of industry called fourth industrial revolution. Connect emissions to the internet through Internet of Things, collect the data in cloud, treat them through AI algorithms, smart metering, set tracking, smart farms as we are seeing. Few more solutions of AIoT. Okay. Drone technology, autonomous vacuum cleaner that can be used night time, they can keep programming it. Smart IoT device controlled via remote mobile app. Okay. Then autonomous car. So this is Tesla, Google, IBM. Then self-driving car using AIoT. Then self-driven car enabled smart IoT. Then smart shopping using AIoT these days. The person when shopping in the market, goods will introduce themselves. When entering the doors, scanners will identify the tags on our clothing. When paying for goods, the microchip of the credit card will communicate which checkout reader. Then when moving, the goods reader will tell the staff to put a new one. So like that, the smart shopping using AIoT. This is actually the Amazon marketing one video. Okay, so this is about summary. There is a video is there, but that will not work out. So as a summary, you can say that AIoT provides a platform that creates opportunities for people to connect these devices and control them, which in turn will promote the efficiency in performance, economic benefits, minimize the need for human involvement, and it's most important for the development of 21st century. So that's all about the AIoT, its applications. Now it is time to interact. If you have any queries, and in fact, I think Professor Satish Kumar sir will show the real-time applications. In fact, he has delivered talk in our programs, also number of programs. So wonderful examples definitely sir will show. So that's why I cut short my talk and focused on the artificial intelligence brief idea, then IoT, and how we can interface AI and IoT. And after interfacing, embedding, what type of applications that we can come across, those things I have told. So any doubts or a clarification, you please respond. You're welcome.
Thank you, Kishore sir, for sharing the valuable viewpoints of AI and IoT system. Now, with great pleasure, I invite Dr. Satish Kumar sir to deliver his expert talk. After that, we will take all the question and answer session.
So I have a great respect to our my mentor and well-wisher sir, Professor Satish Kumar sir. Sorry, sir, I have taken the first talk. So
no. It's
in fact,
really
you should
great.
give the talk. Thank you, sir.
It's really great. Thank you, Dr. Prajita. First, I wanted to thank Institution of Engineers for giving us this kind of an opportunity, which is really a rare kind of thing, because I am sharing stage with Professor T. Kishore. He's really a great talk was there, and I am also thankful to Professor Deshmukh, who is heading this session, and also Dr. Abanti and all the participants who is joining there. So I am going to speak on whatever be the discuss with Professor Kumar. I am going to give you deep insight. So kindly let me know okay, whether my slides are visible uh, to you.
Yes, sir. Yes, sir. It is visible.
It is visible. Great. So I'm going to talk on edge computing for next generation system. See why I have chosen this kind of an area or topic, because the need of the hour. Because when there was a conflict between Pakistan and India, before that we were thinking tank will be in front of that, but nowadays we have seen the drones are playing a very important role. So when drones are there, then we are also taking care for this. Uh, eh, just a minute, I can put this in down. Okay. So drones are having different kind of analytics. So the first thing which is very important is the survival of the fittest, right? Similarly, you have seen when COVID was there, and COVID, we were not aware of that, ki what kind of thing is there, where is the vaccine, how to deal with. So we all are experienced, and we start doing lot of innovation and technological interventions. And after that, not only we survived, but we have done the really great innovation all together at the different part of the country. So if you see, there are different kind of a landmarks in the human history which affected each one's of us life. Like agricultures are there, but the most important which is there is a information and communication technology, because it has affected each one of our life. Because mobile phone is the best example, and mobile phone is giving us a very good connectivity, and not only one connectivity, but n number of things are being performed over this. And even whether it is a illiterate person, literate person, or a whatever be the profession, even rickshaw puller are carrying all these things. And because of that, lot of app are being generated. Things are being delivered at our home because of that technology, and many more things are there because of the ICT. So the important thing is that the technology, economy, and society, because it is said that we want to become the superpower of the world, and now we are fourth economic of the world, and we want to become third power, economic power. But how it will be? Because it is already understood that without the technological intervention, we cannot be. Because the technology is not only replicating, allowing us to import as well as export kind of interventions, because we are spending huge amount to get the products inside. For example, healthcare system, lot of devices are needed, and we are dependent upon the Western world. If we are doing any innovation, that is giving us lot of opportunity, and also the startup ecosystem is increasing. So the thing is that we need to understand the innovation. We need to have a different kind of a networking. Why networking is very important? For example, if we want to work for a agro-based sector, then agro scientists are playing very important role. Similarly, for medical sector, the doctor advice and doctor intervention are very important. Similarly, environmentalists are there. So we need to have a different networking to take care for the domain knowledge and need, because our country needs all kind of a all sphere kind of an innovations. So what ultimately thing is that we are going to have a different networking of society, industrial society, knowledge-based society, and humanity for uplifting the life of the people. So overall, we are going to have a different kind of an economic growth, and economic growth is increasing, and we are targeting for a 5 trillion kind of an economy. So the interconnect between science and technology is that ki without science, technology could not proceed, and without technology, science cannot proceed. For example, if you want to measure PPB kind of level, sensitivity, also understanding the even the hidden facts, the without instrumentation we cannot. So science is a way of knowing and technology is a way of doing, but they are all correlated. But the important thing, two widely accepted consequences are there. कि technological development is a necessity, right? Because we want to uplift, but the technology has to be regulated. For example, we are becoming online, but a lot of frauds are coming up, a lot of cyber security issues are there. So technology is also having the pro and as well a cons kind of thing, but we are looking for that is an important thing. So the most important thing which we need to understand that science with simplicity. You know, nowadays we are doing scanning and Paytm kind of thing, another app we are doing, and we are taking care almost 40% of the total digital transaction happening in the world. So we are proudly saying that okay, 40% of the transaction doing in India. But whether we have understood okay, why it is being there, because you know it is very simple to understand. The quick and error free is there. Another thing, it is more informative because whenever transactions are there, if it is not completed, then money is reverting back and automatically money is being transaction. Even 2 rupee, 3 rupee, easily trackable, actionable. So, but it is not like that. Technology is very simple. But if you understand at the back end, lot of ruggedness is there, algorithms are there, servers are there, networks are there, databases are there, and many more things are there. So ultimately, we should understand the interfaces should be simple as soon as simple as possible. But at the back end, the technology must be rugged. So we are living in a golden era in computing. Why we are saying golden era in computing? For example, powerful multi-core processors are there. Initially, when we were working, it is a microprocessor was there, then microcontroller. Now it's a multi-core. Different core can take care for the different stream, different modality they can take care. Even general purpose graphical processors are there because if we are going to have an image processing, high speed imaging kind of scenario, then graphical processor are playing very important role. Similarly, superior software methodology, the best example is a Matrix UK company is there, they are offering if you do not know the programming part, for example, you are expert in hardware, but you don't know the programming, then draw the flowchart, it automatically convert into the C language. Similarly, you can draw in terms of a FSM, T cycle, and automatically convert into the C language. Another thing, virtualization, leveraging the powerful hardware. The hardware can be virtualization, means the memory part, the communication part, so many things can be taken up. And wider bandwidth for communication, we are not satisfied whatever be the bandwidth we are getting. We want real time, at a no click, everything should be available, lot of documentation to be transferred. And proliferation of devices means 7 billion population, and we are targeting the 50 billion devices need to be connected. So there is an explosion of domain application. There is a agro sector you go, AI is implemented. Medical sector you go, it is implemented. Disaster management you go, everywhere this is being implemented. So therefore we call it a golden era of computing. So, but the one important aspect need to be seen, information for society. Why I am saying maybe for the Western world, people may be having all kind of a connectivity, but for Indian point of view, lot of things need to be done. For example, disasters, coastal regions, they are having different kind of a disaster. Cyclones are there. Similarly, landslides are there. Similarly, earthquakes are there. But if we are moving from one place to another place, we are not getting alert in a real time mode. Similarly, the health point, because you know when COVID was there and how it is being penetrated. Similarly, how much energy we need to consume, what will be the thing, batteries are there, if they are dumped, there will be lot of e-waste will be there. Similarly, climate, sometimes you know prediction are not accurate. Prediction, it is saying no rain is there and it is rain. And so our prediction need to be more accurate. Agri also, we should know how much crops will be produced. Can we take care for the other part of this, because environmental factor will be like that. If we segregate this, like for example, purple revolution was there, where it can be converted into the different kind of economic things is connected. Ecosystem, we do not know what are the birds are available, and for example what are the vanishing one, biodiversity as well. So water, we have not provided the purest form of water to our people, all people, because water is the biggest problem. Lot of health hazards are happening. So all these things, information for the benefit of society, we have to work for AI and IoT based things. So another thing is very important ki, what is intelligence system we are talking about? We are talking about AI, we are talking about IoT, and we are talking about the edge computing also. But question arises that ki, which kind of a discipline come together? But if we want to design an intelligence system, I am saying all kind of an the conclusion drawn from the research of the all material. Say best example is a mobile phone. Mobile phone is also having the glass optics, the sensor, physics, material science, and signal processing, computer vision. Lot of things are coming together and then forming an intelligence system. So we have to break the barrier to understand at least the conclusion drawn from the other streams. So digital world is changing because more devices are becoming online. As I mentioned, 7 billion population, 50 billion devices are to be connected. And there is a huge amount of data is being generated everywhere. And we demand lot of latency with low latencies. And machine learning everywhere, automatic sorting, for example, Apple, automatic sorting of apple, automatic sorting of an banana, automatic sorting of an oranges, automatic sorting of a lemon. So many things are there. So we need cheaper sensor, and important thing is data privacy and regulations is very important. So IoT, the best definition, there are many definitions, and I'm thankful to Professor Kishore, who is very good. He has given the insight of IoT. But to understand what is IoT, let's understand one practical example. Say, for example, any campus, we want to make it, say, for example, intrusion detection system, and after 8 p.m., no man's land and no vehicle zones are there. Then how to implement? There are different multi-modalities are there. Say, for example, vibrations are there. Ground vibration are required because if a person is moving, because you know, camera, there will be IR camera, there can be a visual camera, but power will be the problem. Then IR cameras are there, but IR camera is required, lot of computation, lot of power is required. So we can connect with a primary agent vibration sensor and secondary agent thermal imager, and then also any one more sound recording means microphone can also be installed at the various place. So if any intruder is coming, say a dynamic global network infrastructure means the sensors, it is vibration, it is microwave microphone, it is a vibration sensor and IR imager, and they are having different identities, different physical attributes, what we are extracting from signal, what we are extracting from images. So they are self-configurable capability. If, for example, if the vibration sensor is a primary one, if someone entered, automatically it should trigger the another modality, that is camera or sound one. And using the intelligent interfaces. See, interfaces are very important for whom we are designing a technology. For example, if we are designing a technology for a blind person cannot see, he can feel. Another thing, for example, we are designing for an elderly care person. We are designing for a patient who cannot have another kind of emotion. For example, hands are not there. Then how it is going to voice operated will be there. Siri is a very good example in iPhone. So, and nowadays people are talking about brain computing interface. For example, a patient is there from the brain, can he have a wheelchair movement kind of thing? So another thing, based on a standard and interoperable communication protocol, because when a dense network will be there, everybody is storing, then how data will be stored? Whether we are following a standard protocol, how they are, if suppose any intruder is coming, how it should be communicate, how it is should be compute and then inform the alert system. So the system are seamlessly integrated where physical and virtual thing means sensor. For example, humidity may be there can be a fog will be there, and physical attribute, they are transforming the entire network into a information network. This is a very good example. And now I am talking about the edge computing. What is edge computing? Edge computing, better to understand, say for example, an industrial unit is there where let's consider 25 degree as a abnormal temperature, right? If temperature in a beverage plant 25-degree will be there, then contamination of the entire plant will be there. And we are having a server, client server architecture. Only direction can be given by the server, being master slave protocol. So if it is reached 23-24 degree temperature and is reported to the server that I am getting 24-degree temperature, we know 25 is a crucial temperature. All the beverage plant will be contaminated, but there may be server is busy in taking care of the critical task. He is not entertained and the temperature became 25-26 degree, contamination of this. Rather than that, say for example, if it is 23-degree, it has to act as a master, the node, and node is deciding itself, okay, I am, because temperature may become 25-degree, and taking preventive action automatically, only informing the server a particular packet, okay, I have done this because the temperature was, only a small packet of information are being sent. So there are lot of advantage for this edge computing. Similarly, for example, drones are there. If drone is going and it is coming back, it is all the time it is computing rather than recording only. So we have to come out with where the data is processed locally, the AI algorithms are there, and then we are having a very good fusion block. So the computer science student aware of that, the OSI layer where first layer of physical devices are there, physical layer is there, it is edge computings are there. So ultimately, the definition of edge computing, it is a function of AI, communication, and computation. Computation can be GPU based, CPU based, quantum computing, and field programming gate array. And what will be the advantage of this edge computing? The speed, because every device is, every node is computing its own. So the whole pressure is not on the server. Everybody is computing. So time and latencies are good. And similarly, cost of volume of transfer, we are not transferring all the raw data dumping to the center recording station. We are transferring only the packet of information, the desired one only. So privacy and regulation compliances will be there because the entire data is kept by the individual node and not to be transferred. Only the desired packet of information are being supplied. So you can understand the two aspect where there is a client server architecture. When all the sample are processed, everything is being sent, then there is a full bandwidth, full data sampling, full data storage, and there are a lot of delayed latencies are there. That is not acceptable in the current scenario. The edge node, we are sensing the critical data, we are measuring the critical data. So because only packet of information, so there is a reduced bandwidth are there. So we can design trigger alerts in system, decision we can take, profiles, and reduce latency we can do. So SCI index means, we normally, SCI index is related to the publication, but here I want to say for the technology. Say what is your SCI mean? Which your technology, what is going to sense? what is going to connect, what is going to interact, because this is very important. Where to interact, real time scenario, defense scenario, societal scenario, whether snowbound areas are there or it's a high temperature things are there, what are the different modalities are there, whether single one or a multispectrals are there. So you can see the best example of the edge computing. See, this is a camera, and you know everywhere cameras are there, that all the data is being dumped to the center recording station. But you might have seen the movie Mission Impossible, where this camera is not only having the recording but also having the processing locally and also the AI part inside it. So what it will do, it is going to, let's consider it's a mall scenario. A person is entering and the camera is also understanding whether the person is suspicious or not. It is having its own computation, and suppose it has detected a suspiciousness of a person. Now it is not tracking to the gate. Wherever that person is moving with the PTZ motion, it is moving towards the person only. And there may be, the person may go out of the field of view. Then it is transferring the information to the another camera. Okay, this is a particular packet of information. I have detected this person as a suspicious. You can have your own processing, or you can believe on me with a probability confidence of this much. Then you can understand the technology is really a great, and the cost is also will be there. And there is a huge amount of data being dumped into it. Is said that for every 8 people in US there is one camera, and 29 people worldwide cameras are there. Huge amount of data being there, but we are doing with data nothing. And it is said that only 9% of the data generated being utilized. If we are going to utilize another 9%, then we can able to generate a 1,000 fortune company. That kind of an thing is there for the data, because data is a great gold mine. So another thing is, if, for example, take care of the airport, some object is being lying. What is happening? Somebody is informing. Why? There must be drone kind of a camera kind of a scenario. It is automatically considered this as a suspicious one, and it is also having a processing things, and automatically then it is informing to the designated person कि at this location the object may be suspicious one. So that kind of thing is very important to understand. And another thing, this is a very good thing. A Peter Funch was a photographer. He, what he did, he taken his camera from 8:30 morning to 9:30 in New York, and then he spent 9 years of a time and continuously capturing different figures, different photographs. And after near 9 years, he tried to identify the similarity into this. And then he published a very good book on the, no, name is a 42nd Wonder Built is there. So you can see the similarity he found in 9 years of a data, similar per persons, but he did it manually, right? You can see this music, listening music, then smoking habits, listening music, wearing habits. So the question is that why I brought this here, because the thing is that he did it manually. Suppose we want to do it a automation with the AI, this information is very great, because what this is revealing, it is also telling to the fashion industry what the people are liking. Another thing, what are the drinking habits are there. Another thing, where security is there, because people are not taking care. They are listening music over a very crowded place. They are taking a mobile phone where a lot of movements are there. So this data is a gold mine. But the problem is that on the automatic processing, resolution, contrast, and number of problems will be there. But ultimately, the edge computing is going to solve the particular things which we want to implement. So edge computing can be lower level. If, for example, all the watches we are having, how much steps we have taken. Similarly, the speech recognition, object detection. But the high level of edge computing, you can understand the last one, instance segmentation, where we are having a picture, there we are identifying there is a cat, dog, and duck is there. We are also identifying their locations. Okay, this picture is having that kind of a thing. That is a high level of computation, and high level of computation is the need of the hour. So another thing is a artificial organoleptic system. This is very important because e-tongue and e-nose. Say, for example, you are having a coffee. So coffee, how to find out the coffee is of a good quality, rather than it's a human centric, because nowadays keyboard is available. People are taking sip and moving coffee here and there or tea, and after that they are grading. On the basis of their grading, the cost is being decided, and then they are chewing another tablet to remove the impact, and then again taking another sip. But I am thinking maybe the 100% effect has not been removed. Why it should be persons specific? Can we design a probe? Probe can be like taste bud need to be converted into the sensor array, and then all the brain neurons are there, different kind of a feature can be extracted, and then different neuro features and pattern recognition. Then we can classify on the basis of that. If these kinds of system we are designing with the artificial intelligence, you can see the beverages where tea and juices can be quantified, water quality can also be maintained, pharmaceutical drug analysis can be there, clinical diagnosis will be there, and there will be petrochemical adulteration, fermentation, sweet analysis. So lot of application are there, but they are very novel one and new one. Another one, the healthcare point of view. See, there is a paradigm shift. We are not asking for the treatment of a patient. We want enhancement of our health also. Even we are healthy one, but we want our good health management. We are not talking about the disease management. We are not talking about the patient compliances. We are talking about the health experience. So from patient, we all are customer because we want good health. So you can see this is kind of a thing, the textile electrode. Why I want to record the BP whenever it is required. The mobile phone is available with me, and the chair on which I am sitting, there is an electrode. And all the time, after maybe every 1 hour, it is being recorded, the Holter kind of thing situation. So I can see why my BP was high. So like that, there can be lot of wearable devices can be taken care. Similarly, this is very important. I have seen taken this picture from Germany when I was at Germany. So what we are doing when we are driving a car, first we are sitting on a chair, the car seat, and seat is having electrode. Then we are having a belt. Belt is also having electrode. Then skin impedance. You can see there is a health index telling the what is the heart rate of a person, another parameter. If the person is not able to drive or some health problem is there, it is automatically alarming. So I thought suppose that will be converted into, for example, drink and drown. Drinking, after drinking, lot of people doing lot of rough kind of an driving, so accident can be avoided. For example, it can be automatically minimize the speed. Another thing is that drowsiness, because at 4 a.m., 5 a.m., when we are driving, we are in a in between stage of a sleepiness. So at that time, maximum accident happen because it's a fraction of second. So if that something is there, no NDT based thing, and we can alarm in a real time so that a driver and health can be maintained. And this is also electronic portal imaging device which we have devised. You can see that this part robotic arm, this is very important one because nearby the lot of people are having cancer, and you can say 729 district we need 3 4 medical linac machine we required. So more than 2000 machines are required. This was a Siemens machine, and we have designed this robotic arm. What is happening when cancer was there? So people are, doctor is saying ki go for a radiation, say for example 15 days, 10 days or 21 days. Doctor is aware of the initial health, and then at the end he is aware of what is happening. Maybe the 21 days it is spent and no effect is there. So rather than that, the robotic arm is going beneath to the person. When live doses are being given, outside we can take care whether doses are being reaching to the particular tumor or not. And on daily basis, real time we can see whether the tumor size is increasing or decreasing, because there is a dynamism required whether plus delta X dose to be given or minus delta X dose to be given. So that can be regulated, and rather than having a complete black box, we can have a real-time assessment of daily basis. And you can see with having this robotic arm, the cost of this machine can become 20 CR, and without that is nothing. It's an 1 CR kind of thing. So I am saying this kind of a critical involvement is required. And another thing is urine analytic healthcare. This is of my friend Nikki Jha is there. What he thought, he's going to install these kind of a devices in a different part of the country, and then a person can urinate and he will take a minimum amount kind of thing like 100 200 rupee, but he is providing the test of a 3200 rupee, but he is ensuring the privacy and security of a person, but he is utilizing the data can be used for a particular sector. For example, glucose problem will be there, then there will be creatinine uric problem or other problem can be there. So he is earning from the data, and data is being generated like that. That is a very good example of a startup who is coming with a great initiatives. So another application is that when pilot is there, pilot is going, and then free fall of a aircraft is there. At that time, the acceleration is becoming 10G, and at that time there is a possibility of a brain hemorrhage. And we are aware of that there is a EEG signal and EMG signals are there. We can capture that stage, but because of the protocol, pilot are not allowed to wear anything. So all the things we have to do in an NDT method, like we can take a camera, we can take care of a sound, then automatically processing in a real-time mode, we can tell that pilot is going into that state. Then it can be regulated from the ground to save the life of a pilot. This is very important technology or need of the hour. Similarly, elderly cares are there. Everybody is talking about the elderly care. And sometime, a mother was there who is having his son working in US, 17 days sea ride. So we all are concerned with our elderly people, whether they are in a good state or not. So people have given lot of innovation. Some person is saying they have given a foot, means sandal is there and there is accelerometers are there. But again, person problem is there. We are not taking slippers during sleep. In even South India, sometimes people are not taking shoes inside the house. Then people said, okay, let's have an thermal imager, visual imager. Again, that is related to privacy of a person. Then people have given that kind of a pulse glass where a small dot and all kind of a data can be there. And then this data can be correlated with the person is ideal sitting, talking while sitting, walking. But again, the problem is that when person is sleeping, he is also removing that part. So people are sometimes offering that kind of a belt also. But again, the belt normally we are not wearing. But again, the people are trying with two kind of an accelerometer and then try to correlate whether the walking stage, falling stage, or lying. So lot of innovations are being there. So another thing is a photonic nose. You might have seen the fiber bundles where lights are coming in houses, and that bundle can be converted into a health probe. For example, if we breath and then all the door order can come to the that side, and if we will have a hyperspectral of that imaging, and then we correlate the disease, for example, neck cancer, the liver cancer, the lung cancer, or kidney related problem. That is a very good examples are there. For example, this fiber bead, and then automatically different vector knowledge base are being created, and then from the pattern recognition we can have a health diagnosis, and then another with the this vacuum pressure base, the effect can be removed and it can be used for the another patient. Similarly, for example, drones are there. You can see nowadays what is happening. Drone is going and they are dumping huge amount of data. But rather than that, I am saying when drone is going with the edge computing platform, it is also having processing inside. So when it is going, automatically image is being taken. When it came back after 45 minutes of a flight, it will tell, okay, I have a span of a 10-kilometer kind of an say railway track, and I have observed one fault of A kind, two fault of B kind, C kind at this location. Now you can see it is very important. We cannot take care of the trillion data. It's a terabyte of a data to process it offline. It will take months together to understand. The moment it is coming, it is informing. Similarly, the another example, say consider this is a China border, and for example, he is a Chinese soldier. Rather than that, drone is going there and it understood for example, when it come back, it is already taken care at the low level. Detections are there, some soldiers are there, and then high level segmentation, recognition, then also connecting with the NLP, and then when it is coming back and it is informing, I have detected a person. He is standing on a grass, looking towards a mountain. There is a clouds also there. There is a fog also there. Don't you think this information will be an important one for our soldiers? But it is having all the onboard processing, all the edge computation. The moment it came, automatically it is processed. But the lot of intensive efforts are required to understand it, and also the probability. What is the probability level? Somebody can say, "Okay, I can only say 40% of my confidence," but somebody is saying 90% of the confidence. That is very important. So this is the work we have done for seismic sensing based edge computing platform. These are the geophones we have designed, and this is a edge computing platform we have designed. You can see the different kind of an seismic wave are being penetrating. So because of to understand these waves, we can identify whether the signal is related to animal, signal is related to human, signal related to vehicle. So we are having different kind of an application for the same. So you can see for border like a scenario or a campus critical campus scenario where we discuss about the IoT. So what it is there, first signal is there and ground sensors are there. They can be buried also. So once they have detected, then camera is automatically activated. So this can be applied to a critical infrastructure in a nuclear facility, critical facility, refineries, or a college life facility. So this is a very important aspect we have implemented our edge computing. Similarly, another one is the UWB radar. This is a radar, it is having a transmitter and receiving frequency. Normally, ultra wideband is working in the range of 3.1 to 10.3 gigahertz. We have used 3.1 to 4.8 antenna, and the advantage of this is that even the bushes imaging can be there, and also behind the wall also be there, and crawling of a person can also be detected. You can see a person is having simple walk, and the importance of this is that 168-degree field of view is there, and even in the swimming kind of scenario the person can be detected, and it is having lot of scientific applications where we are using this also for the elderly care. When fault detection is there, we are using this technology. Another thing is that I have seen this picture from frontline, maybe during 87, 88 or 91, Latur earthquake was there. So I have seen this picture when the Swiss people came, and during Latur earthquake, they have used the sniffer dog. Then I try to understand कि eye is there, I mean camera they are inserting, ears are there, they are inserting the microwave, and they are using the sniffer dog. So rather than sniffer dog, if we will convert them into the gas sensing sensors, whether we are able to detect the person is alive or not, because 72 hours are very important. So 72 hours of detection are really important, but no multi-sensing head is there and no foolproof technology is available. Even rather data was not available. So by motivating that, what we did, our PhD student, they have generated this data. These are my PhD student, five simulated victim we have taken, and this was a construction of a site. We try to generate our data with multani mitti, and also you can see the different contrast where number of bodies are available. Somewhere darkness is there, somewhere multiple human being are there, somewhere partially body are being seen. You can see this, and after generating this data we try to process it, because the complexity of the environment is a lot, because lot of bags are there, contrast are there, partial body are visible, and then we have published this data on the IEEE data port with a simulated disaster victim, and it is available open for all for doing all kind of a research. And then we try to identify how our eyes are going to distinguish between the cloth color and the skin color. And then we did a lot of algorithmic work on that, and that is also published in the IEEE Sensors Journal. So another important problem, we worked for the elephant railway conflict, because elephant is coming on a railway line, either they can hurt or train get derailed. In both the scenario, there are a lot of things are there. 50,000 crore losses of the countries are there, but people are not working over there. So what we did, we went to Rajaji National Park, and here is a dense forest. We established two zone for the same with edge computing thing, and then try to understand the camera. This camera is not only the camera, the core is there. We have designed our own edge computing, how that data will be processed. You can see elephants is available and huge amount of data being generated, and then we design one LEC alert system based on the vibration and LE thermal alert system, then connect it to the command and control. And this work was considered among the top 50 idea to save elephant in India. And we have been asked to present our work to the Malaysia on the 29th International. We are also shortlisted for AI solution for Himalaya. And now the most recognition was there. We got patent in Bangladesh, and Bangladesh Asia Development Bank for Chittagong Cox Bazar Rail project. They have considered the project like us. Our project has been considered as a model project by the international community, and our team has been invited to evaluate their project. So another last important thing I want to mention about why earthquakes are there, because we talk about the disasters also. Earthquakes is happening because of a lot of motions were there, and Eurasian plate were very high, and that has been collided, and still that movement is going on. But earthquake prediction, if you see the probability, people are predicting there may be 8 magnitude earthquake in this region. When it will be, we do not know. And we know country is divided into the different zone. Now there is no zone 1 is there, zone 2, 3, 4, 5 are there. So technology are full-fledged and we do not have earthquake prediction. The people are saying there are different theories are there. People are saying radon gas is increasing in water. Sometimes they are saying, but the radon gas is also increasing due to the industrial surcharge, discharge they are doing. Sometimes people are saying that animal are having odd behavior, but when it will be earthquake, how much magnitude it will be. Sometimes people are saying frequency is changing, but and there will be more faults will be there. But faults are there because of the cable cutting and lot of things. So what we did, because prediction is not available, but you talk about sensor processing, AI, system, edge computing, communication, everything is there. So what we did, we try to understand these waves because there are different waves are there, and you can see कि primary wave and secondary wave, P wave travel along the axis and S wave travel perpendicular to the axis. So P wave are horizontal, means they are along the axis, but their speed is very high, 6 km per second. The perpendicular to the axis 4 km per second. So we have taken the difference of velocity and then try to generate a system that is earthquake warning system. It is having lot of inbuilt capability. And then we designed a network for Delhi Metro, Mundka Metro, Bhavan, Botanical Garden, Faridabad, Huda City, and then try to connect, generate the alarm. And this system was third in the world to demonstrate after Japan and Mexico. We have demonstrated this, and this is the GUI generating the whole alert system in a real-time mode to Delhi Metro. And then because of our intervention, we became on the international world map. We got our place because that has been demonstrated in a real-time mode. And DST website also reflected when it was alerted in a real-time mode. It is a 10-year, 24 into 7 our technology is working from the last 10 years. Another thing, we are getting lot of recognition and awards for this technology. And this is the technology when tectonic plates are moving, then a signal are generated and then moving to the instrument. And then instrument after processing giving in alert to the different vital installation. So this is a earthquake warning system. So actually, theory is seeing a green kind of an environment, but when we are working, it's a truly the practice is like that. So that's all. If any question is there, I can take up. I think I am well within the time. So let me know if any questions is there.
Thank you, sir. Thank you, Satish, sir, for the wonderful presentation. Uh, Respected dignitaries, esteemed speakers, member of the Institution of Engineers India, faculty colleagues, researchers, industry professionals, students, and dear participants, as we approach the concluding segment of this technical webinar on AI, IoT, and edge computing for intelligent real-world applications, it is my privilege to briefly summarize the key discussions, insights, and takeaways from today's deliberations. At the outset, this webinar successfully highlighted the convergence of artificial intelligence, Internet of Things, and edge computing as a powerful enabler of intelligent, responsive, and efficient engineering systems. The sessions collectively emphasize that intelligence is increasingly shifting from centralized cloud platforms to distributed edge-enabled architecture, enabling faster decision-making, reduce latency, enhanced data security, and improved system reliability. So, from the first expert address provided the valuable insights into the academic and research perspective of AI-driven system, the speaker emphasized the role of advanced signal processing and machine learning techniques in extracting meaningful information from large volumes of sensor data. The discussion clearly brought out how AI, when integrated with IoT frameworks, can significantly enhance system autonomy, adaptability, and predictive capability. Another important aspect highlighted was the interdisciplinary nature of modern intelligent systems. The session demonstrated how electronics, communication, mechanical system, computer system, and data analytics must work in close synergy to realize practical and scalable solutions. The role of academic institutions in fostering such interdisciplinary research and skill development was strongly emphasized. The talk also underlined the importance of capacity building and skill development, particularly in the context of Industry 4.0 and emerging technologies. Emphasis was placed on aligning curriculum, research, and training programs with real-world engineering challenges. The second expert address shifted the focus toward the real-world deployment and national-level applications of intelligence systems. It offered a comprehensive overview of how intelligent sensor, embedded systems, and edge-based AI are being successfully implemented in some critical domains such as smart cities, disaster management, surveillance, early warning system, and defense applications. A key takeaway from this session was significance of edge computing in critical environments where real-time response, reliability, and data integrity are of paramount importance. The discussion clearly demonstrated that processing data at the edge not only reduces dependency on cloud connectivity but also enhances system robustness and operational efficiency. Across both the sessions, several common themes has been conversed. These include the need for scalable architectures, energy-efficient edge devices, secure data handling, and explainable AI models to build trust in intelligent systems. Ethical consideration, data privacy, system accountability were also touched upon the essential components of the technology development. So, with these words, I conclude the today's summary of the proceedings. Now, the session is open for question and answering. Now, I request the participants, if you have any query, any questions, please unmute yourself and please.
No, madam, questions are being arrived in the question answer button below. Kindly take the questions from there.
Okay, sir. Okay. Yes, so there is one question has been come from Dr. Abanti Datta. So we see a high level of automation in the weld shops and assembly lines here. So how is edge computing or IoT being used for predictive maintenance on these robotic arms to prevent downtime on the production line? So this is the question.
See, thank you, ma'am. This is a very good question. See, how we want to see, because you see abnormality detection. Because if any abnormality is there, there will be a lot of faults will be there. So, say thermal images are there, which is going to tell us the different kind of machines whose health is also being observed by seeing the temperature profile. If, for example, temperature profile of a particular device is increasing at large, so we can generate or we can take preventive action, number one. Another thing is that whether we are performing the right kind of a thing, that is also being monitored, because if any fault will be there, that will be amplified over the 1 hour, maybe the whole day. That is also can be taken care. So there are n number of things, not only for the SMD, but SMD also for which particular segment you are going, whether padding for the defense application is there, or it is for the societal application we are talking about. So accordingly, also there are different steps need to be taken care. So accordingly, we can minimize.
Thank you, sir. Thank you for the
Okay,
valuable
ma'am.
answer.
Dr. Banti, ma'am.
Yes, so thank you for the clarification. So there is another one question, that why is edge computing preferred over cloud for real-time robotic adjustment, and what mechanical failures are prevented by having this intelligence local to the machine?
See, ma'am, edge computing and cloud. See, cloud is a distributed system. It is maintained by the different enterprises sometime, and there is a security issue, and also it is a client server kind of an architecture, as I mentioned. When we are having edge computing, then everybody is a master. So there is no dependency. The security is more enhanced, and the decision is being taken locally. So whenever any abnormality or a mechanical thing or any kind of a thing, locally it is decided. And also, for example, n number of nodes are there, 10 nodes are there, so 10 are computing simultaneously, rather than all data is being dumped at a particular thing and then processed all together. Then lot of delays and everything will be there. When locally is there, we can also distribute. One particular node is doing one particular task, another node is doing another particular task, and then collaborative sharing can also be enhanced, so more intelligent in a much better efficient way.
Thank you, sir. Now there is another question, sir. For heavy duty electric trucks, is there a shift toward multi-speed transmissions to optimize motor efficiency? And how is the regenerative braking system mechanically integrated with the traditional air brake systems used in heavy vehicles?
See, heavy vehicles are there. You talk about first the engine and all these things. See, again, because for this predictive maintenance, people are using IR profiling. IR profiling is going to tell the what is the spectrum of totality work. If, for example, already mentioned, if there is a spike of a temperature or there is a breakdown is there, no abnormality is there. So two kind of a scenario people are using. One is a acceleration base. Acceleration, because a different contour and different signal will be there. If any abnormality will be there, even screw loose will be there, the spectrum of the signal will vary and its frequency will vary from low to high one. Similarly, for temperature gradient is also vary. So by seeing that, we can also see whether there is an abnormality, whether it is a heavy truck or whether it is a small truck or it is a plant, whether it is a electric plant, whether it is a mechanical plant. It's really matter. But the important thing is that locally it is being taken care by the single modality like imaging, or it is signal plus imaging modality to have a more authentication. And similarly, talked about the brake one also. Brake one, because how we will come to know brake? Because it is going to a smooth manner. So particular sensor, for example, accelerometers, so they are generating a spurious frequencies. When spurious frequency, why? What is the lag? What is the looseness is there? What is the tightness is there? So all these things can be taken care because already recorded data is there that has been mapped whether they are matching, if how much correlations is there. On the basis of that also we can generate that kind of a signal. Is there any other question related to this?
Yes. eh,
Yes, ma'am.
Okay. Thank you, sir. So there is another one question. So how AI will be help in manufacturing in MSME sectors?
See, MSME is also now growing, right? So another thing is, for example, I am taking simple example, additive manufacturing. Like additive manufacturing are a very complex scenario, and then we are mapping layer by layer. We are taking care for the lot of validation we can do in a real time mode, because everything is moving in a automatic way. So automatic way, whether that is correct or not, because later on they are going to give the problem. For example, a bone is there that is going to be inserted to a particular thing. So during manufacturing only we are taking care about the health, how it is being there, process is optimized or not, whether the uniformity is maintained or not, because sometimes machine is having different speed. Initially, for example, layer is there, but there may be some kind of variability may be there over the time. So over the time, that kind of a variability and all these things can be taken care. Therefore, they can also enhance the productivity. Similarly, for example, there can be a die and mold and n number of things are there. So MSME sector can also take in care for the all the AI intelligence manufacturing and the right component also. Hello.
Yes, sir. Okay. Thank you, sir. Sir, there is another one question. IoT is playing important role in agricultural sector, that is drone, climate control, polyhouse, precision agriculture, but only limited to few progressive farmers. Will the scenario change in near future and more number of farmers get benefited?
Yes, ma'am. Nowadays, lot of NGOs are coming, which is giving benefit, and also the CSR laboratories, they are giving benefit to the farmers. For example, the Purple Revolution. Purple Revolution was there where no cultivation was there over the Jammu and Kashmir area. Now people are having very good oil they are producing, and because of that, all the technology are being given to the farmer, and farmer are being trained, and there is a lot of skill programs are going on, and they are using the technology when there was no crop war there, and now they are earning huge amount of money. So that is known as a purple revolution in the country. That was demonstrated during the last 15th August also by the CSIR. So lot of initiatives are there towards that. And every, because see, one particular, it's our country is dense, and we are having a different kind of an South India, North India, east to west. So lot of research institute, lot of NGOs, even the individual one, we have to play a bigger role to get them acquainted with the technologies, right? So but the day are not far away. If you compare from 2 years, every time there is an exponential growth.
Okay, thank you, sir, for the valuable answer. Now there is the another one question, that is how does the AI-driven computer vision system detect micro defects in engine blocks or chassis welds that might be invisible to the human eye, and how does this feedback loop automatically adjust the mechanical welding parameters?
Yeah, it is known as a MEM subsurface defects, because from the surface it is a very smoothness we are seeing, but there will be cracks inside. So outside we cannot see. So there are what we have to do. We have to take care for the imaging, and imaging can be different kind of an IR heaters are there. So that particular part is being heated, and then heated we are going to have a different kind of a scan, and then scan can also be only different frequency based, and then we will take different contour, and by processing that image we can identify how long cracks are there and how deep it is. So there are that kind of, and that kind of thing we can do from the image processing with the heating of this thermal imaging actually. That is known as subsurface defects.
Thank you, sir. Thank you for the answer. Now, the next question is, are there standard AI models specific to various tasks or industries?
No, it's not. And see what we are going to do. What is your ultimate target? Two things is there. For example, people are saying, I want the highly accurate one, right? Sometimes people are saying, I want at the earliest one. I can compromise my accuracy, but for example, 80% accuracy will be enough for me, but I want earliest result. Another one is that I want highly accurate, time is not important. So there is no standard one. Our algorithm, how we are going to optimize them, because for example, image processing, 30 hertz frame rate is there. How much frames we are going to process in a real time mode. And also machine learning also plays its important role. Similarly, how much evolutionary computing, because data is being varied under the different environment, how we are going to take care that. So everything depending upon whether we are working for a high speed, say for example, steel is there, steel is being produced under a very high temperature zone. High temperature zone is a high speed camera different. So it vary whether we are talking about a simple camera to the high speed camera, and also the environment. Similarly, fog environment, snow environment, and number of things are there. So there is no standard things are there. Ultimately, what is your target? What is your objective? What is your application? Say, for example, I want to design a defense application. It should be highly accurate, right? If I am designing simple a toy kind of a thing or simple detection, so everything depending upon whether I am using CCD camera or I am using a high-speed camera. That is the thing.
Thank you, sir, for the valuable answers. So right now there is no other question in the chat box.
Thank you, ma'am.
So now I am handing over to IEI, Kinshuk sir.
Thank you, madam. So this is the time for the vote of thanks. Distinguished panelists of the session, the chairman MCDB, moderator of the session, and the participants. As we come to the conclusion of this insightful webinar on AI, IoT, and edge computing for intelligent real-world applications, it is our privilege to propose the vote of thanks on behalf of IEI headquarters. First and foremost, we express our sincere gratitude to our esteemed panelists for sharing their valuable knowledge, expertise, and real-world insights. The session beautifully highlighted how AI, IoT, and edge computing are transforming intelligent systems and addressing practical challenges across industries. Sir, your thought-provoking explanations and examples have truly enriched our understanding. We extend our heartfelt thanks to the Institute of Engineering and Management for their sincere efforts in planning this webinar on this contemporary topic. Our sincere regards to the Mechanical Engineering Division Board of the institution for constant encouragement and support in promoting such knowledge-driven initiatives in the nomenclature IEI technical webinar. We would like to thank all the participants for their active involvement, insightful questions, and enthusiastic presence, which made the session really interactive and engaging. Last of all, we are grateful to everybody who contributed directly or indirectly to making this webinar a grand success. With this, we once again thank you all and hope that the knowledge gained today will inspire further learning, innovation, and collaboration. Thank you. One announcement only, the e-certification portal is open till tomorrow midnight. Those who want to obtain the e-certificate, please follow the link given in the webinar flyer. Thank you.
Thank you, sir. Thank you very much.
Thank you, ma'am.